Okay. 2.7 is function and mathematical models. Like I said, this class is business class. They designed for business, marketing, accounting students, right? As opposed to, pre-calc, that's for pure mathematics. This is more like a business route. So you see a lot of practical models in this class. Here are, before we actually go into a problem, let me show you way to formulate your mathematical models. So there are many types of mathematical models that you're gonna see. Either they can be prediction models, like linear regression, right? Or they model involve one or more variables. They call multivariable problems, which we're not gonna see in this class. Second, once you formulate your problem, you're gonna solve using appropriate mathematical approach or technique, right? Each model has their own techniques. So first, recognize the model and then use appropriate technique for that model. Once you solve the problem, not everybody is math people, right? People who actually manage, you probably manager, right? They probably doesn't have a lot of math knowledge. So once you solve your problem, you're gonna put it back in English, like interpret them. What does it mean? For example, if you solve for the slope, what does the slope mean in the context? If you just throw out the number, they probably don't understand what it is. And then last, you want to test the accuracy of the model. If it good, if it match what you're looking for, then you stop. If it not, maybe you pick the wrong model. Right? Go back and pick another one, solve again. So that's how math works. And that's how math professor work too. We do our research and we just keep doing it for years until we find the result. Hopefully we find the result. So here are some examples of, first we're gonna talk about polynomial function. Polynomial function is the easiest function to work with. Why? Because it's continuous, right? It's continuous. You put your finger on the graph, you should trace it smoothly, right? With no jump, no gap, no hole, no sharp corner. Right? So it's a very good function to work with. The most basic polynomial function is the constant function. Okay. Say y equal a, where a is some real number, is a constant. What's the degree of the constant function? It's polynomial, it's gonna have degree. So what is the degree of the constant function? You did it on your exam, and most of you got it right. 0, right? I can rewrite this as what? A times x is 0. X is 0 is 1, so just a. The second one is the linear function, mx plus b. So go from 0 degree to the first degree. And then the one we just did last, which is the quadratic, ax squared plus bx plus c. So those are friendly ways of describing 3 basic polynomial functions. In general, they're not going to write like that. In general, you see something like this. Whereas a naught is your constant, right? And then you go up 1 degree, one at a time, right? ax squared, ax cubed, ax4, all the way to ax n to the minus 1 and ax n. Right? Where all your a subscripts are your coefficient. They belong to the real number. However, your power belong to the natural number. So a naught, a1, all the way to an are coefficients, and they are real number. They belong to the set of real number. but your n is your n. Maybe I highlight in blue. The power is the I would say whole number, not natural number. Because natural number is start from 1. Whole number start at 0. Basically, it's a non-negative integer. So n belong to the set of integer. I'll put plot plus, so it indicate that it's non-negative integer. Z stand for integer in German. Yeah, I don't know what it is. But it's the first letter of integer in German. Like I said, polynomial function is a continuous function. So its domain gonna be what? What is the domain of the polynomial function? Everything, right? Everything, like I said, is a smooth graph, right? So everything everywhere is defined. So negative infinity to positive infinity. I want you to take a minute on this example and let me know which one is a polynomial function and which one is not and why. So talk to each other, or rather people at home. Think about it. Number one, what do you think? Yes or no? Is a polynomial? Yes, right, it is. My coefficient are all real number. So 2, say 1 there, we don't see it, but it's a 1 there. And then 0.6, they all real. And then my power belong to the non-negative integer group. So yes, everything is in order. Everything follow rules. So yes, they polynomial. We're gonna say yes. What about the next one? Is it polynomial? Pull up my notes. Is it a polynomial? What do you think? Oh, what make you being indecisive? What do you see? What is Pi? Okay, pi. She say pi make her feel uneasy. Anything else? Anything else make you uneasy? Is pi real number? Why not? I can plot pi approximately, right? It's an irrational number, but it's belong to real number, right? Remember your don't write this down, but remember your set of number. You start with counting number instead of all natural number 1, 2, 3, 4, 5, 6. That's when you learn when you're first grade, right? Or even kindergarten. And then what's next? Whole number. 1, 2, 3, 4, 5, 6, and then include 0. That's whole number. And then integer. That's a Z right there. Include negative number. Count but include negative. Don't write this down. And then what's next? Do you guys remember? I'm running out of color here. Rational number, right? Denote script Q, stand for quotient. If it's not rational, we call it what? Irrational, right? We call it irrational. So I'm just gonna say irrational here, right? That's like pi, e, right? Those number or square root of 2, square root of 3, things that you cannot put in fraction. Right? What else? What cover everything? Real number, right? Real number. Subscript R. And what is the biggest one? Complex number, right? Imaginary. Denotes script C, right? So that's your set of that's number set, right? The natural number when you learn when you're kindergarten, and then as you grow, as you go to high classes, your knowledge of number expand. In college, you should be able to know up to complex numbers, right? And that's everything. So even though pi is kind of different than 1, 2, 3, 4, 5 or 0.5, 0.9, you know, it's still a real number, so it's okay, right? It's a coefficient. The other thing that make you uneasy might be the missing the degree. I say, Mimi, I don't see degree 4 and second, and I don't see the constant term, but that's okay, right? Because if I see the missing degree, I can replace with what? 0. Right, I can say 0, and 0 is real number. Right? So yes, second one is a polynomial. Even though it doesn't look, you know, perfect. And again, all my power R belong to the non-negative integer. What about 3? Is it polynomial? No, she shook her head. She said no. Why is no? Yeah, the square root of x. What does it mean? What's the power of square of x? You better write it in rational form. Will be what? X to the 1/2, right? And 1/2 is not natural number. Remember, the power only belongs to the non-negative integer. 1/2 is not integer. So because of that, it is not. What about number 4? Finish polynomial. Two things to be polynomial: real coefficient and non-negative integer power. So do we have real coefficient? Yes, yes. Do we have non-negative integer for power? Yes. What else? How many variables do you see here? 2, right? Polynomial have only one variable. So because they're multi-variable here, no, it's not. Number 5. Number 5. People in the from home, you can put in the chat if you wanna show your input. It's a polynomial. I don't see multi-variable, so it's okay. Yes. Lexi said yes. Anybody else? This one okay. This one okay. Look at this one. What happened to the x? It's in the denominator, right? So here's x to the first. If I bring up, what happened to my x? It's the -1, right? So you have a negative negative integer for your power, which is bad. So no. What about the last one? I'm sorry, not last one, number 6. I know it looks so much like polynomial. Uh, it is not. It is not. I know it looked very much like it. It looked like a perfect one too. The reason is not because it's what it's not finite. Polynomial is finite. Remember the definition? It stops at n terms. Here you have infinitely many terms. That's called series. So, yeah. The last one, yes, right? Yes. If you expand that out, distribute them. All right, hopefully you'll be able to distinguish what is polynomial, what is not. Let's take a look at this example. Global warming. Do you believe in global warming? Global warming, the increase in carbon dioxide in the atmosphere is the major cause of global warming. There's other gas too, like methane, right? But CO2 is the major gas that caused the greenhouse effect. The Killing curve, named after Charles Dave Killing, a professor at Scripps Institution of Oceanography, gives the average amount of measure in part per million. I call that ppm, ppmv, in the atmosphere from 1958 through 2013. Even though data was available for every year in this time interval, we'll construct the curve based only on the following random selected data points. They have more data, but we're just gonna take a look at these data points. Okay. Oh, sorry. So that's your data point. A mathematical model given the approximate amount of CO2 in the atmosphere during this period is given by this. It's a quadratic, right? But it's polynomial. Where T is measured in year. I forgot a T here. So I remember to fix. T is measured in year with corresponding to 1958. T equal 1. All right. So start from 1958 is T equal 1. 1959 T equal 2. What T equal in 1970? Is it 12 or 13? Right, 13, because you start at 1, right? You're gonna account for that. So you add 1. You take 70, subtract 58, and then add 1, right? So 13 here. And then 74, there'll be 17, etc. Use a model to estimate the average amount of CO2 atmospheric in 1980. So 1980 is 23. 80 minus 58 is 12. 12 plus, I'm sorry, 22 plus 1 is 23. This one is simple. All you do is just plug it in. What did you have? Oh, I put 13. Should be 23. You're gonna check your result on your own too. Okay, I have my answer, but it might be wrong sometime. 337.7. Don't forget unit. 90% of the class lose 1 point because you forgot your units on the problem. Number 9. Okay. part per million volume. So that's easy. Assume the trend continue. Use a model to predict the average amount of CO2 atmospheric in 2022. So 2022, what is my T? What you're gonna do, and then you add 1. You got 2022 minus 58, that's 64, right? Plus 1 is 65. Here, 415.1 part per million volume. So far, so good. Problem is not too bad. So that's polynomial. There are 3 more functions I want to introduce to you. The next one will be rational function. We learned about this before. I don't know if you can remember when we learned about domain. Remember? Domain. Rational function is a polynomial divided by a polynomial. Right? The 2 polynomial combined together. So the domain for the rational function is everything except for the denominator cannot be 0. An example with this will be, ratio. So if I say r of x equal x squared minus 1 divided by x plus 5, what is the domain here? Everything except -5, right? Everything except -5. So that's rational function. Power function is a function of the form f of x equal x to the r, where x and r are real number. Is it polynomial? Is it like a baby form of polynomial, you think? No, it's not. I know it looked very tempted, but power functions are not polynomial. Right? I'll give you an example. I'll use blue. Say f of x equal square root of x. What is the power of square of x? Oh, I'm sorry. What's the power of x here? 1/2, right? So remember power function, the power is taking real values, where at polynomial function, the power only take non-negative integer. I'll give you another example. F of x equal cube root of x squared. If you change it into rational power, do you guys remember the boot method that I talk about? The little boot method. One of the professor that taught me how to do that. It's your little winter boot right there. You click you kick the 3 over. Let's go underneath the 2. So there'll be x to the 2/3. Power always on the numerator, and then the index will be in your denominator. Locked it. So that's power function. Now combination function is everything in one function. For example, I can have something like this. Maybe I'll call it g of x. I can have square root of x plus 1 over x minus 3. is in the form of rational function. It has a power function on the top, and it have a polynomial function in the bottom. So all four in one, all three in one. Do you guys remember how do I do domain for this function? If I have something like this on the final, you know they have this something like this on the final every year, never failed. Find the domain of the function. What is the domain? Well, tell me one thing that you know. X cannot be 3, right? That's one thing you know. What else? Well, the numerator, if the numerator was the polynomial, then we just that be done, right? But it's not polynomial, it's radical, and it's even index. So everything underneath an even radical has to be what? At least 0, right? So because you guys did not do very well on the domain part on the exam. So let me remind you again here for the sake of the final. X cannot be 3. That's your first thing. And then the other thing is that x plus 1 is at least 0. And then you solve for x. You put down the value. -1 and 3. I cannot take 3, so I'm going to put a hollow dot there. I can take -1, so I'm going to put solid to indicate it's included. Can you talk about the Oh, really? How come I don't see anything here? It's supposed to say, usually it's pop up, so I let you in. I don't see anything, so sorry. All right, so x cannot be 3, and x has to be at least -1. So from -1 to the right, and then you skip 3, and you keep going. So the part that highlight in red, that's your domain. So your domain will be from -1 up to 3, not including 3, union from 3 to infinity. On your exam, I think both of them on the denominator, listen. Both of them in the denominator. All you have to do is what? Instead of greater or equal to 0, use strictly greater than 0. That's all. Everything is the same, except this part will be instead of 5. So don't mess it up again on the final. It's not that hard. Why don't you try this one? I'll walk around, see how you do. I suggest you pull it up from your phone, and I post on Moodle. Because there's another page for the question. Let me ask you this. Is this one power function or polynomial function? The one I highlight in blue. It's a power function or polynomial? Yeah, thank you, Lexi. It's power, right? Because the power is in real, right? Polynomial power is in non-negative integer. And use this model, estimate the average cost per mile of driving in 2012, medium-sized sedan, 8,000 miles per year and 18,000 miles per year. I'll walk around, see how you set this up. It should be very easy. Into these problem passages, you actually understand which variable X, now X is in thousands. So they give you 8,000, you should plug in just 8. So X is in thousand. I have 96.3 cents. Is that what you got? Per mile. You don't forget the unit. No. And then the next one, lazy here. Instead of 8, it's gonna be 18. 18. I got 56 cent, 56.1 cent per mile. All right, those are easy one. The last two is something more like your exams question. I'm not gonna ask you this an exam, that's really easy, right? The last one is more like your exam stuff. Construct a mathematical models. Giving you a story problem. I'm not giving you the function. You're supposed to construct it and solve it, right? So that's what you're supposed to see. Here are the guidelines. first you're gonna assign a letter to each variable mentioned in the problem. If you can draw a picture, try to draw it. If it doesn't have not the picture type of problem, then you don't need a picture. And label the figure too. Second, you're gonna find the expression for the quantity salt. You're gonna have a interest function and a constraint. There might be an interest function and there might be a constraint function, right? Which I'm gonna show you. So you might see a constraint function and the interest function. Like the name suggests, the interest function is the one that you want to work with. So what do I use a constraint function for? To substitute stuff. I'll show you what I mean by that. And then step 3, we'll talk about that. Let's take a look at this example. Patricia wishes to have a rectangular garden in her backyard. I see picture, I'm gonna draw one. I'm gonna denote W for width and L for length. You can do X, Y if you like. She has 80 feet of fencing with which to enclose her garden. Let's denote. Oh, sorry. They already tell you what to denote. My bad. All right. So just do what they tell you to do. So let's denote the width, and then okay, as you know the width, and then Y. It'll be Y. It'll be the length. Then. Okay. Find the function f in the variable x given the area of the garden. Don't worry about the domain. The last question we'll talk about later. But our main thing right now is you want to find the function f in term of x that represent the area. All right, that will be your interest function, right? Because you want to find the area. You're interested in the area. So can you tell me what is the area of the rectangle here? What's the area of the rectangle? X and Y, right? Yes. So area will be X times Y. My problem is, how many variables do I see here? 2, right? The problem say you want to write the function of f in the variable x only. I'm gonna find something to substitute y. That will be from my constraint function, right? And a constraint function come from this piece of information. What is it? What does it mean? 80 feet to enclose the garden. If I take this side, at this side, at this side, at this side, what is it called? Perimeter, right? That's 80 feet. That's your perimeter. The perimeter, if a rectangular, will be 2x plus 2y. So P equal 2x plus 2y. And you know what P is? That's 80 feet right there. Move this down. 2x plus 2y. Can I divide both sides by 2? equal x plus y. I'm gonna solve for y, right? Because I need to substitute y into the red function. So y equal negative x plus 40. Now you can write y in the function of x. So what we're gonna do next is we're going to substitute this, that blob right there for y. Instead of a, I'm gonna replace it with f of x because now it's a function of f in the function of x. Yeah, a function of x. So x times, instead of y, is going to be negative x plus 40 Let me rewrite this. So far, so good. Oh, that's just one line. You can move everything. That's how math works. What kind of function you have here? All right. Find the function f in the variable x given the area of the garden. We done that part. All they want is finding the function f, and we did. If you want to distribute that out, you can. I'll leave it like that, and I'll tell you why I'll leave it like that, because the next part, I'm looking for the domain. I wonder if you guys can see by right in yellow. You can see it. Now the domain, what is the domain of this garden? What's domain mean? Domain mean when you plug a number into this function, it makes sense, right? So in terms of practical thinking, the area of the garden has to be at least what? 0, right? You cannot have negative area, right? So the smallest value you can take is 0. Maybe I should distribute that out. I'll leave it, it's fine. So domain in yellow here. The area has to be at least 0. Well, it cannot go to infinitely many amount, right? You have a finite garden. She had only 80 feet for fencing. So has to be at least 0, and then the maximum value you can reach for the arrow will be what? Hint. I'll give you a hint. You look at this. Yeah, you look at that. 40, right? 40. You cannot go more than 40 because x plus y is or yeah. So that's what you're gonna do. So you plug into the area that is x times negative x plus 40 is greater than 0 and less than or equal to 40. What I'm going to do is I'm going to set equal to 0 first and equal to 40. So set it equal to 0. Equal to 0, and then you solve. So either x equals 0 or x equal 40. These values right here, I don't know, you remember they call critical values from 661, 662? Do you guys know how to remember inequality for quadratic? You know, test point and all that. Maybe should I show you that? Should I show you that? Yeah, I'll show you it. I have time. I'll show you. I'll show you how to solve for it. If you're confused about why I get the 0 and then the 40. Right here. Right, the work down there. So I have x times negative x plus 40 less than or equal to I don't want to. It's the same thing. I don't want to. It's the same thing. There's two parts. You're gonna solve it greater equal to 0, and x times negative x plus 40 less than 40. For both parts, you're gonna have to find your critical number. This is just recall. Find critical numbers by setting each factor equal to 0. So I have x equals 0, negative x plus 40 equals 0. So I have x equals 0, and x equals 40. My soundtrack in the background. Sorry, guys. No, there's no problem. Just wake them up. Thank you. All right. So my critical number, I'm gonna put a number line. And I put in my critical number right there. Smaller one first, and then the larger one next. And then I'm gonna pick a test point. I don't know if you can remember this. It's long times ago. TP for test point. From negative infinity to 0, pick anything from there. Anything you like. Say negative 10, negative 5, doesn't matter. Between 0 and 40, pick one. Say 10. And from 0 to infinity, say 50. And what you're gonna do is you're gonna plug into the inequality right there to test. 5. When I put negative 5 there, what do I have? Sorry. Again, I don't care about the value. All I care about the sign, right? So negative 5 here, negative 5 there, and then the negative in front will be positive 5. So positive 5 plus 40, that's positive. Positive times negative is negative. Right? Again, I only care about the sign. Plug in 10 into the inequality. 10 for x, and then negative 10 plus 40, that's positive. So positive times positive is positive. And then 50. Negative, right? Negative 50 plus 40, that's negative 10. And then times a positive 50 outside, that's negative. You want the negative interval or positive interval? Positive interval, right? Because your original inequality is greater equal to 0, right? So that's why you so here x is at least 0 and less than or equal to 40. And if you saw the second one, it's the same thing. You don't have to do that. Maybe just one. You're gonna have the same answer. Yes. So what the test is that, what you just squared up, is that how you want us to answer it for time? For me, good enough if you can see this right there. When you have x equals 0, x equals 40. And for me, I automatically know it has to be in this. It had to be, right? It cannot be greater than 40, right? You don't have infinite many amount of fencing, right? It gotta be between those. But if here the next slide, I kind of elaborate out how do I get the answer, right? So maybe you feel more comfortable if you saw one of those inequalities. Does that make sense? So these are review from 661. No. 62. Solving quadratic inequality. All right, last one, and we call it a day. Charter flight revenue. If exactly 200 people sign up for the charter flight, Leisure World Travel Agency charges $300 per person. However, if more than 200 people sign up for the flight, assume that this is the case, then each fare is reduced by $1 for each additional person. Let's actually note the number of passengers beyond 200. Find a function given the revenue realized by the company. So let me do some scrap works here. So here I call scrap work. Before that, I'm gonna, so let's act, oh, they already wrote it for us there. I don't have to rewrite it. I was gonna say, let's actually note the number of passenger beyond 200 people, but they already wrote for us, so. Now, if I had exactly 200 people sign up, how much the ticket per person? 300. So 200 people times 300, do you know how much you make? How much for the tickets total? So this is exactly 200 people. So plus 0. That's why I say I have plus 0 there. If I have one more people sign up, so 200 people plus 1 people, then what is my ticket price? It reduced by $1, right? $2.99 or 300 minus 1. If I have 2 more people sign up, what happened? How much my ticket price now? It reduced another additional $1, right? So $298, right, for that second person. So instead of 298, I'm gonna write it 300 minus 2. Do you see where I'm going with this? I'll do one more time. Third person. So I have 203 person, or 200 plus 3. With my color here. And my ticket price would be 297, right? Or 300 minus 3. All the way down to what? All the way down to X number extra passenger, right? And what is 300 subtract what? Subtract what? X, right? 0, 0, 1, 1, 2, 2, the pattern. So that's subtract X. You know, mathematician, we don't sit there and count. We find pattern. And that is your function. We're done. So f of X, the function that represents the problem is 200 plus X times 300 minus X. Oh, I'm sorry, minus X, not minus 3 over here. One last one, I'll let you go. The domain. Seems like the hardest one for you here. The domain, it had to be what? How many people should I have? That's the question. I cannot have infinitely many people, right? It's not infinite hotel, right? There's a certain amount of seat on my plane, right? So X is greater or equal to 0. Well, it has to be at least 1 passenger in order to operate the plane, right? Up to what? I know I can go beyond 200. Right? 200 is not your maximum volume. Up to what? 300, right? What happened? You go beyond 300, you have a negative thing here, which is wrong, right? Can't have negative money. Right? I mean, you're taking loss, right? You're taking a loss. So you have to be up to 300. That would be your domain. Or you can solve. You can solve like I show you how to solve up here. Same thing. Right? Or you can use your logical reasoning. Right? So your exam, expect one of these two. It's the next exam. Which one you like better? You want this one or you want the garden? Huh? Careful. The garden one is every problem is similar, but this one I can twist it a little bit and all of a sudden it's changed. Yeah. Yes. I haven't opened it yet. Oh, sorry. Let me fix it right now so I don't forget. I always messed up on that part. Your extra credit, you have until near midnight, 11:55 p.m. You are linear algebra. I'm sorry, linear programming. What do you mean it's not open? It's open, right? Oh, okay.
Yeah.